One example of a weighted average is to compute a grade in a class. So for this example, we have a grade is determined by quizzes, exams, and a final. So there's 8 quizzes, 2 exams, 1 final exam, but the quizzes are worth 20%, exams 50, and the final is 30. So these are the weights. They tell you how important each category is. So let's see. The weights do in fact add up to 100%, so this does make sense. And below here, I have all the students' grades listed out. So here are 8 quiz grades, 2 exam grades, and the final exam. So I guess to start with, we need to average the quizzes and the exams before we can apply them to each category. And since the lowest quiz grade is dropped, we're just gonna get rid of this 25. But to average the other quiz grades, we add them up and we divide by the number of them that there are. That would mean that there would be 7 left over. And you can do this out on a calculator, so let me compute that. Okay, so I get roughly, it's like 565 divided by 7, and that's about 80.7. So I'll just count that as 80.7. And okay, for the 2 exam grades, we have a 50 and a 60. I mean, we could obviously, add these up and divide by 2, but I know that's going to come out to be halfway in between, which is 55. That's a pretty low exam average. And well, the final didn't go much better, also a 50%. But now the question is, well, how do you take these 3 values, this 50, this 55, and this 80.7, and combine them to figure out the student's overall grade? Well, this is where the percentages, the weights for each category come into play. So what we're going to do is we're going to take the 80.7 and apply 20% to that. We'll apply 50% to the exam average and 30% to the final average. And I'll change those all to decimals and put it into one equation. So it would look like this. We're going to take 20% of 80.7. And we're going to add to that 50% to 55. And then we're going to add 30% to their 50 on the final exam. So this will be the formula. You take the weight and you multiply it to whatever they got in that particular category. I mean, if all of their grades were 100, I mean, you would just be adding 20, 50, and 30, giving you 100 overall. But I can just figure this out right in my calculator, so I'm going to type that out. Okay, after putting that into my graphing calculator, I get a 58.64, so you can check me on that. I mean, you can round a little bit, maybe that's a 59, but either way, that is an F overall for the semester for the student. And I guess one other final thought is, for an average, you're typically dividing by something. And that means you're dividing this whole expression by a number. And that number would be 1. The sum of the weights should be 100%, and written as a decimal is 1. Okay, maybe as a more interesting example, we'll take the same, the same student, the same class, same quiz grades, same exam grades, but I want to switch it up a little bit, where this student has not actually yet taken the final exam. And, any student could be in this position where you're worried about passing the class, you haven't taken the final. It's a reasonable question to try to figure out, is it still possible to even pass this class? So I'll say pass with I put 70% here. For some classes, it's required that you get at least a C- to be allowed to take the class, so I'll use that as the standard here. So the question is, the student has the same quiz grades, the same exam grades, but they haven't taken the final. What do they have to get on the final exam in order to get a 70% in the class? So I'm going to call the final category X. It's my unknown. It's what I'm solving for. I'm going to try to solve an equation to get my answer. So, we'll drop the 25. We're going to average these grades out, but we're going to get the same thing as last time. Okay, so that's an 80.7 for the average. Again, for the average on the exams, it was a 55. And we don't know the final grade, but we can still plug everything into the formula just like in the previous example. So it would look like this. Okay, we have 0.2 is multiplied to 80.7, 20% of their quiz average. Okay, then it's going to be 50% of their exam average, which was a 55. But now we're taking 30% of something that has not yet been determined. And we know what we want the grade to be. We want the overall grade to be a 70. And technically, really we're saying, greater than or equal to get at least a 70%. But it stands to reason that, if we know what it is for a 70 and the student gets a better grade, that would mean at least in this example. So I'm just going to get rid of that and we'll solve it for equals and just note that, that's at least. Okay, so to simplify this, I'm going to take all of these values and combine them together, and ultimately my goal is to solve for x, so I'll combine that. Okay, so I get 43.64, so that's 43.64. Then I have plus 0.30x is still equal to 70. I'm going to subtract this 43.64 from both sides. Okay, so we get 26.36, so 0.3x is equal to 26.36. And now we'll just divide both sides by 0.3. So dividing both sides by 0.3 will give us our value for x. Okay, so 26.36 divided by 0.3, and I'll write that off to the side here, but I solved for x, and I got 87.86 repeating. That's really about an 87.9 approximately. So that would be, a B plus average on the final exam in order to get just at least the 70% in the class. So, that doesn't seem impossible. In my class, I definitely review a lot for the final exam, so there wouldn't be any surprises on it. But here's one way where you could use the concept of a weighted average and a linear equation to answer a question about your grade in the class. There is a second part to this question. Can the student get an A? And I think on my syllabus I have that as, a 93. So that would go in place of here. So you could go through the same process again, just to put 93 in place of that 70 and solve for x. But it doesn't look like that's going to be possible. Another approach would be you could take the x, and the best grade you could get on the final would be 100%. Maybe at this point, a better question is what's the best grade I can get? And putting 100 in place of x would tell you that. So I encourage you to try solving this equation for, instead of a 70, a 93, and see what value you come up with. And, ask the question of, do you think that is possible for the student in this class?